to our next slide. Again, we're going to talk about what's going on with the control of the heartbeat, because sometimes your heartbeat does speed up a little bit, sometimes it does slow down. So let's take a look at what's going on with that. Our first bullet, heart rate can be controlled by the autonomic nervous system, the part of the nervous system that responds automatically to changes in body conditions. So you can think, okay, autonomic sounds like automatic. Your body is going to respond automatically. Your heartbeat is going to respond automatically to the environment that it's in. So what your body is doing based off of the stimuli around you. Looking at the second bullet, where myocardial contraction maintains the beating of the heart, we may need to speed up or slow down heart rate. So we talked about earlier how the myocardial contractions keep the heartbeat steady. It allows the heartbeat to do what it's supposed to do on its own without you having to think about it. But sometimes we need to speed up the heart or slow it down, again, based off the environment. So looking at our third bullet, when exercising, more CO2 is present in the blood. This is detected by chemoreceptors in the brain's medulla oblongata, which we talked about before, which is right by your brainstem. Okay, and it's resulting in a nerve signal being sent to the SA node of the heart to speed up the heart rate. And remember that SA node, I think you can see it in the picture right here, is at the top of the right atrium. It's going to allow those electrical signals to be sent. So I want you to, if you're sitting down, get up, do a little jog in place for a second, and I want you to analyze yourself of what's going on in your body. So take a second, get up, move around a little bit, run in place. What's happening to your body? Okay, hopefully you've noticed that you started breathing heavier, right? Your heartbeat started going faster. And that's because there was more CO2 being used or being produced in your body. So you're trying to take in more oxygen because your chemoreceptors were like, uh-oh, we got some increase in CO2. We need to breathe in some more oxygen to allow that oxygen to be pumped throughout the body. So your heart is going to be like, okay, no problem. I'm going to speed up my heartbeat so then I can push more oxygen out to the rest of the body. So when CO2 levels fall, on the other hand, another nerve, the vagus nerve, reduces heart rate. So if you are just hanging out, you're not doing much, you're not using that much energy, your CO2 levels are going to fall because your body isn't producing a lot of it. And that's when the nerve vagus is going to allow your heart rate to decrease. So if I'm just sitting here and I'm relaxing and I'm enjoying the view of my backyard, my heart rate is going to be much slower than if I was running around and doing a lap around my yard. Also, you might have heard of the hormone adrenaline, and this hormone causes a rapid increase in heart rate for our flight or fight response, preparing the body for action. So I always think about if you're home alone and let's say you're in your bedroom and there's a noise in the kitchen and you know that nobody else is home, adrenaline's going to start pumping into your body because you're like, oh my gosh, is somebody in the house? Do I need to fight or should I get out of here and run away? Okay, so your environment is going to allow your body to react, and that reaction is going to allow some hormones like adrenaline to have an impact on your heart and specifically increase your heart rate. So this effect can be mimicked by stimulant drugs as well. So if there's a change in your body's environment and different stimuli, that's going to cause a reaction in your body, and that reaction is going to have an impact on your heart rate depending on what's going on. So looking at our side picture here, I want you to go in and press the link and go through and take a look at how the electrical signals are being sent throughout the body. Again, this is a good overview to take a look at. I also want you on the side of your notes packet to pause the video for a second and look at these two questions. So can you convert the control of the heartbeat into a flow chart? And two, how is it an example of negative feedback control? I want you to answer these two questions. So pause the video for a second, take a look at the video that's linked in the note slides, and try to do those two questions on the side of your notes packet. So take a pause. And then last but not least, Here's a nice overview of what's going on with your heart and the different things that are playing a role on your heart. So looking at your brain, now remember the medulla oblongata in your brainstem is a huge plays a huge role in the heart rate and how fast your heart is going to beat. So again, looking at it, we just talked about it with like adrenaline, if you're running around or if you're staying calm. First, looking at your sympathetic nervous system, that's going to increase your heart rate. So again, if you're running around and you need more oxygen, your heart's going to beat faster to send that oxygen to your body. Also, adrenaline is going to increase your heart rate because you're going to think, okay, should I fight or should I flight? And then down here, we have the vagus nerve that we talked about. Again, if you're just relaxing, calmly watching a show, TV, your heart rate's going to decrease in comparison to when you're running around. Also, the adrenal gland, that's where your adrenaline and epinephrine plays a role. So the gland is going to push out the hormone adrenaline, also known as epinephrine, to also increase your heart rate. So your brain is having an impact on your heart, your glands are having an impact on your heart, either increasing it or decreasing it. So I hope you enjoyed this video of going over the electrical signals. For today's classwork, now that you've taken the notes on the electrical signals and how the heartbeat is controlled, I want you to go back into Google Classroom, and we have two things for, one thing for classwork, one thing for homework. So for classwork, you're gonna open up this this worksheet here and go through and use the words that are bolded and the topic words, and you're going to go to the diagram here and label what exactly is going on with the medulla oblongata, what's going on with the glands down here, what are they producing, and how is that going to have an effect on the heart? Is it going to increase your heart rate? Is it going to decrease your heart rate? Is it going to make it stay the same? So taking a look at that, that's classwork for today. And then homework for today is going to be a cardiovascular health web quest. So for homework tonight, I want you to take a look at all of these different links and go through and analyze and discover different things about cardiovascular health. So that's going to be your homework for tonight. So again, if you have any questions, please feel free to ask. Make sure you look at the different videos that are posted for today's control of the heart and the electrical signal that's in the notes slides itself. Please feel free to join the Google Hangout as well to ask questions, to discuss anything, or just to say hi. Miss you all, and I hope to see you very, very soon. Have a great rest of your day.